Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Talk. It's my great honor to have Professor Ting to give a talk on his work in OCR and face recognition in Microsoft Research. Professor Ting is a full professor at Tsinghua University, the top university in China. And she has been my professor and teacher when I was in college and during the PhD. Professor Ting has been focused on research work in optical character recognition and recently face recognition for over 20 years. She has a lot of achievement. She certainly published a lot of papers and won a number of awards. But the most impressive to me is how many product Professor Ting has been deployed that has been impact millions of people's life. For example, the optical character recognition engine of coming from Professor Ting's lab has been used in Office 12, that's Office XP, and it is powering the OCR recognition for all language except English. And Professor Ting's work extends well beyond just Chinese. They cover, to my knowledge, Korean, Japanese, Tibet, an array of extended array of languages for all kinds of optical character recognition, and her team has been working on not only printed character recognition but also online and offline handwritten recognition, signature recognition as well. One of the recent adventure of Professor Ting is developing a face recognition engine. And this face recognition engine has been used for the custom border between Shenzhen and Hong Kong. And it is being used for fast border parsing between these two areas. Just imagine if the similar system can be deployed in the airport. You don't have to wait in line in the airport because your face is your passport, and you can quickly pass through the security checkpoint because you are recognized as a reliable and trustworthy person. And we can get rid of our badge and just simply pass into the building because our face is basically our badge. And Professor Ting also developed solutions that can track containers, and this solution has been used in New York Harbor to track basically the container shipped to the harbor. Her lab has also been developing solutions that can scan various forms of written materials, for example, text form, recognition for envelope, and all these array kind of things. I firmly believe the expertise of Professor Ting is invaluable, and it's our great pleasure to hear a true expert and share the experience of her 20 years research work on OCR and face recognition with us. Without further ado, let me pass the podium to Professor Ting.
Thank you. Good morning, everybody. I'm very glad to visiting Microsoft Research Center. Have the close cooperation with Microsoft, and I hope they have the close cooperation with Microsoft. Today I just introduced some research work in our lab. My talk name is Intelligent Image Processing. I think this name may be good cover our research in our lab. The original title is From Character Recognition to Multimodal Biometrics, but I think we research maybe broadly. everybody knows that now is the information society. People close each other today through the internet. So a lot of the information, special for image information, is mostly important and broad information. So only for image transformation, not enough. We have should have to extract automatically get the information and the content from the image. This is intelligent image processing, the main purpose. Our group is mainly focused on this goal. That is from the image, extract the content. Firstly is character, because character is mainly the carry a lot of the information. Second is man and man moving object, and detection, tracking, and analysis. So our group research focus on this direction. The important intelligent image processing researched in our lab is character recognition and document recognition, analysis, understanding, and face detection, tracking, and recognition, and multimodal biometrics authentication, such as face, write, signature, and iris, and video surveillance, video content understanding, etc. The all introduced is like this. Briefly introduce our research work is the character recognition firstly. They have the document recognition technology has reached the top level in the worldwide. They have the Chinese document recognition, including multi-phone printed Chinese character OCR, online and offline handwriting Chinese character recognition, and the camera OCR, form recognition, etc. The second is Oriental language character recognition, including Chinese, Japanese, Korea, and the minority language document recognition. The second main area is biometric authentication and video surveillance, face verification and face recognition, and multimodal fusion biometrics authentication, active video surveillance. This is the main content today we introduced. There have some introduces about that introduced some main important award have got in our lab. The one is the first is multi-phone printed Chinese character recognition system that won Chinese National Science and Technology Prize in 1992. The second is integrated Chinese character recognition system on National Science and Technology Prize in 1999. They are including printed Chinese character recognition, online Chinese character recognition, and offline handwriting Chinese character recognition, form recognition together. This is the integrated Chinese character recognition system. Third is high performance Chinese, Japanese, Korea, Oriental language document recognition system on the National Science and Technology Prize in 2003, including recognition-based electronic published system with the received document layout and the Chinese, Japanese, Korea document recognition system. the National Science and Technology Prize, that is in China, is the top level prize. We have got 3 times. This is face authentication testing, FAT 2004, on Bangkok database. I have got the best all performance face verification algorithm in the 2004 face authentication test. And our lab have a cooperation with a lot of the foreign company. Mainly is license our software to foreign company. They have the Motorola, IBM, Siemens, Microsoft, ScanSoft, Nokia, Samsung, Omron, etc., including the printed handwriting, online handwriting, and face recognition. This is a license note for Microsoft Office 2003, use the THOCR. Now introduce Chinese character recognition. Chinese character recognition, a lot of form in the printed Chinese character recognition, Chinese character. How to get the much high recognition rate, it is very important. So the very important contribution is that we can get much higher recognition rate in the variance font and the variance noise, poor quality document. It is very important for application document recognition system. So the different font, please look at the font. Sometimes it's more than this one. We have the research on the camera OCR. So sometimes the character maybe is very variance, not very definitive font. So how to show tap this variance and much higher classes, because there have the 4,000, 6,000, maybe 20,000 characters, get much more variance, get the high recognition rate. It is very important and a challenging problem. We have got the very successful results. The second is online handwriting recognition. Do you know handwriting is very important interface, human-computer interface. So a lot of people like use the handwriting, including tablet, PC. So how to get the very, very high recognition rate, it is very important. We have developed our algorithm. This algorithm is including the a lot of the information. Here I have some trees, the writing trees, and some space information together. So we get no recognition system can recognize 27,000 characters, and the variance can, if the character can segmentation correct, we can get the more character recognition rate. More, if the write more regularly, that is is the stroke is more clearly or correct writing. So recognition rate in 19.8 to 19.9. Some character is more cursively, maybe 19.5 to 19.8. They have the and this system have the embedded in the PDA and the cinema phone. So we can get the much small kernel, is high speech. Here is the Samsung used our handwriting, the kernel in this system. The offline handwriting character recognition is also very important, but here is also a very challenging problem because everybody write is different. So how to solve this problem is also a difficult problem. The this have the long way to research, solve this problem. But we have got the very successful result. That is in regular handwriting Chinese character recognition rate is 99, like this rate. Cursively, like belong is cursively maybe 19.2, 19.3. That it depends on the samples, because we have not collect more samples to lake training, so reduce the recognition rate. There have a lot of application in China, like the check recognition, ID card recognition, envelope address recognition, etc. The next is multi-language character recognition. Here is all we all have done the recognition language: Chinese simplified Chinese, traditional Chinese, Japanese, Korea, English, Tibetan, Uyghur, Kazakh, and Arabic, Mongolia. There have the lot of the different language, different shape. Like Chinese is block. It is boundary is very clear, so easy to segmentation. But like the Japanese, Korea, the same. But for the Tibetan also can segmentation easier, because his the boundary is clear. But Arabic character recognition, it is very difficult, as I said, belong. This is also researched system. That is THOCR Unified Multi-Language, Multi-lingual Document Recognition Platform. Different language use the same platform. That is easy to exchange some content. They have the maybe. Sorry. You can see this. The last here is Tibetan, Arabic, Korea, Japanese, etc. Testing the performance. We have the testing. This is tested by ScanSoft for the worldwide the OCR system. This is some result. The testing special samples owned by ScanSoft, I don't know, because the testing is by ScanSoft himself. That testing is ScanSoft for Microsoft for testing for simplified Chinese, traditional Chinese, Japanese, Korea. They have the compare Chinese, Japanese, Taiwan, background, Japanese, Korea, different software package. So from here, can see all systems have reached the top level in the worldwide. There are some samples for Tibetan. They have the not block characters because the longer is vertical is different, and they have the different characters. We have got this for character recognition rate can reach 99.79%. Document can reach 97 to 98%. This system have been used, application used. There is the Uyghur equal similar to the Arabic. They are different because the director is different with the English from left to right. He is from the right to left. Difficulty is that his boundary is not clear. Boundary longer, short. So how to get the isolated character segmentation is very difficult. And this is Mongolia. Mongolia is vertical, and also he have the line, vertical line, but the boundary is not clear the same also. So also difficult. There have some Arabic language introduced compare merged some English and numbers. They have the double direction characters because Arabic from right to left, but English and the number is from the left to right. So sometimes it is make the difficult too. They have the skew. So the performance, we have the testing the performance, multiphone document recognition. A multiphone, the orbit kind of the document is character reached 99.83. The document over 19.6. And they have the double direction document segmentation and the display that is different. Now this is for the multilingual document recognition. Next is the automatic document analysis and the document layout reconstruction, because they have some document should be automatic segmentation, and they have some no block kind the document analysis. It is very difficult to analysis. So we have done this one like this background. So we can correct segmented this kind of document. And also they have because document analysis is also a difficult problem, because the document layout is open problem. Cannot know clearly how to lay out an arrangement. So we have used a lot of vision performance, vision similarity, and vision silence to segmentation in the previous, and that used the ordinary traditional document analysis algorithm, so we can get the much high recognition rate. So in ICTA 2005 computation, I have got page segmentation computation award. So use this document analysis and reconstruction, we can get the recognition-based automatic electronic publish system. They have the layout analysis, recognition, layout understanding, layout rule, then get the output, the PDF, PTR, HTML. So we can get the layout reserved electronic document publish system. This is the result, the newspaper, the automatically analysis, then reconstruction in the left. In the right is reconstructed document. This is the original result like this. We have in China now a lot of the newspaper have been digitalized into the database. So this is use our system. Other is just a very lucky, is a very very funny technology. That is because Chinese character is a lot of fun. Everybody know we can look at every character. I don't know the content. We can know, we can recognize his font. That is independent content font recognition. This is a difficult problem because the content is different. It's Chinese maybe more than 6,000, is 4,000 character different structure. But we can depend on the one characters and not care his content. We can automatically recognition his font. This sometimes it is very difficult because like this, the same sound, same font, but variants different. They have the maybe different font, maybe similar, because here is the Hei, the Yuan, the different, but look like the similar. But we have get the much more high recognition rate. This is, we can look at the one character, we can get 99% the recognition rate. And the more characters, we can get the high recognition rate. That is very interesting things. Not for the automatically the recognize the font, average Chinese character font, but this is very important pattern recognition problem, because because the font information is embedded in the character structure variance in it. In this case, we also can recognize the font. It is very useful. It is very interesting results. They have some application for character recognition. The first is mail envelope Chinese address recognition system. This is cooperation with Siemens, like this. The handwriting. The first is localize the address line and the segmentation and get the result. This is difficult for handwriting. Is segmentation easy because sometimes character is touched together or some part of the apart. So how to get the correct segmentation, that is a very important things for handwriting Chinese character recognition. There we have used some grammar, bigram content. We have used his geometric information, his recognition information, and biometrics language information together. We can get the much high recognition rate. Because the character envelope sometimes handwriting, sometimes is printed, and sometimes have labeling, have windows. So this kind we can automatically through different kind of envelope. This is result printed envelope correct rate near 19.7. Handwriting envelope correct rate near 83. They have the other is very important application in China because that is value-ended text. Text that is sometimes make false text to get from the government, so hard to get the income. Financial income. So this is very important project in China. We have developed a system can correct, recognize here some the characters, more than 100 characters. This is the cycle 密钥怎么说？密钥。Yes. So this system can guarantee the government financial income. Now this system is broad used in whole China. The recognition rate more than 90%. This is also some check, handwriting and handwriting Chinese character and numeral recognition. This is system hardware. Next is camera OCR. Everybody knows the camera is very cheap and flexible, used in every day. So use the camera to get the image, document image. That is easy way and we're broad used way. So how to develop a system to can direct recognize camera get the image information. That is very important. There have some problem should be resolved because this character is not binary, it's grayscale. So we character recognition directly on the grayscale recognition. This is the first one. The second is difficult, how to detect the natural sense, the characters. So it is very difficult problem, like this. The complex background have the characters. The human being can easy to find the characters, but the computer do not. So we have developed our algorithm to detect the characters and then segment it to recognize. So we can know the content in the image. There is the common use, the license detection. There are license from the background, complex background to detect the license place, localization, and then segmentation correctly, and after that to recognize. So not use directly on the binary image to recognition because they can lose a lot of information. So we directly recognize the characters on the grayscale image. This is a container. Container, the container numbers. They have the number to automatically control and manage in the port is very important. So we developed the system for first is localization and the segmentation. After that, the recognition together. This system have used in the New York port by ESC company. This is embedded camera-based OCR on the mobile phone. We can catch, you use the mobile phone to catch the business car, can read the information. There is a special some phone number or email number to input the database. This is some camera take some perception distortion to recognize, to direct, correct, and recognize. This is the business car can correct it and recognize. This is some natural things to detect it. This is some sample, like this complex the page, first page, different color, different characters. We can automatically extract the characters, then get the recognize. Because camera OCR first emit a lot of the distortion, found distortion, so you should be correctly like this. As page have the distortion. So if the correctly, if the not corrected, so have the wrong recognition rate. After that, we correctly, we can get a much higher recognition rate like this. Compare Chinese character before normalized the recognition rate belong 60, but after normalization 19A, so much higher improved recognition rate. This is like this. Next, we introduce some multimodal biometric authentication and video surveillance. Biometrics is very important, especially after 9/11 in America. So this is biometric authentication mostly based on the pattern recognition, based on the image pattern recognition, and improve get the much higher recognition rate. That is very difficult. We have to face detection, localization, face iris signature write, and fusion in our lab has this kind of work. This is like the face detection. That is the face detection in the front face. That is much easier, but in deep rotated, it is difficult. And this is not in the deep, just in the direction rotated. That is not very difficult, but difficult is that deep rotation character detection. And after this face detection is search in the whole page, and consider the different size face. So we should be, so search whole page should be different face model, different size search whole page, and variant size search whole page. So it is sure we can detect much more face in the image, but more image maybe spend more time. And after that, for face recognition is the iris eyes localization, because based on the eye location to normalize the whole image, whole face image. So image eye localization and mouth localization. Sometimes eye localization have to get the some result, but difficult to get very exactly face localization, because sometimes take glasses, and sometimes the with the person is much close, with eye is much close together. So it is sometimes difficult to get exactly the result. So we have to develop the algorithm based on the whole eyes match method, not only for Asia like this. So we get the much higher recognition. This is our system. In our level have used 3 years, the registration, everybody. The moving blue pose expression have changed. This is the face recognition, show different the size variance. This is we tested in 100,000 face recognition. The tested the rate. They have including some font expression variance, deep rotation, Asia variation, etc. Total first candidate can reach 89%. This is for 1 million database to face recognition. Is total for one first one the candidate first candidate recognition rate is 92.4%. This is just for recognize the one person is 2 seconds. One per person second or 2 seconds. So it is fast in ordinary the compute. And this for the FAT 2004, the database, different kind the face samples. They have some variance. This is the result. We can look at a lot of the research group who have attended this computation. The Tsinghua University is the last 2 lines. We can look at the Tsinghua average error is the 1.39%. Other is maybe much more. Near is the 3.33. So Tsinghua University, the result is much good than other groups. They have another testing. Is the Tsinghua University is the 2.221%. This is equal rate, area rate. Other is much more much higher than Tsinghua. This is the result is third testing. Tsinghua also the best one is 13.47. This is very difficult in the outside and the variance, and now the situation is much poor situation. The result is so in this one, the best the performance all belong to Tsinghua. So we get the best overall performance face verification algorithm in 2004 face authentication testing.
Can you say more words about the evaluation there? Who sponsored the evaluation?
Yes, ICPR 2004 responsible for the in this the special FAT 2004 group. Maybe response is Kittler, Cambridge. He is chair of the ICPR 2004.
So all is our standard. Every site has the same training set and test set.
Yeah, it just give samples before, but not enough training samples.
So every site will have freedom to choose whatever to increase their sample size by whatever data they have.
Yes, he can. He can do that because he cannot provide enough samples.
Okay.
This is a face application, face verification application. This is the picture taken from the Shenzhen to Hong Kong custom port. This system from the last year, 2005, June 16, to get until now. Now is the broader near the he prepared to 140 channel, 140 channel. Now Zhuhai custom port also the new set the channel too. We have got the phone number arrived the USA. Get his okay. In 1926 today this year, January 60 to set up the running. So this is very important because Hong Kong to Shenzhen is much high, much more person. To a lot of person to check in is waste a lot of time and human being. So now automatically it's more than near the one now near 5 million person have been through the custom already. The through recognition rate, through correct rate is 97.3%. So that is very, very important for currently for us because this is really application, really broadly big people use the application in face recognition, face verification.
So what if a mistake is made with a 2.7% of error? So if that happens,
sometimes he cannot through. That is say you cannot through it.
But 2% is a lot, right?
But you can sometimes because here have some person to, if you this automatic throw, you cannot use the
Oh, you have to go the other backup. Okay.
But 97% is you use a lot of the things.
Is that what is that rejection rate?
Yes, yes, we get rejection.
It's not truly the correct rate, right?
Yes, this is a verification. Just okay, you is the person who you are. You can through. This is correct.
Right, but if that person is not indeed the person he claims to be, will the system be able to figure that out?
Yes, you give some thing or you cannot. The gate have the rule. The gate have the rules. Yeah, you cannot through the gate cannot open. You cannot through this channel.
He's asking the false positive.
False positive, we have the tested belong 1 point, maybe in the 0.1% FAR. But this time, yeah, it's in Hong Kong to Shenzhen to Hong Kong. Most is make a lot of people through it. The most person is correct. It's yeah. The few, very few is yeah.
But those are most important scenarios, right? You want to catch those people who claims that he's a person, but actually he's not. Right? That's the most important.
For example, you deploy the system between U.S. and Canada borders, and you can make the false positive rate small for certain kind of high dangerous people. I mean, maybe the system is good enough for average use, and your border parsing more efficient.
Right, but my question is actually not that. My question is, how can you know this false positive rate?
We have the offline. We have the tested. Yeah, all systems. I have the tested by myself. We have the some database, which we testing our system.
Are you using the data collected in this real application, or you are using a different test set?
Yeah, not use this testing set because yeah, because really know somebody is the first person we can catch to the police office. Yeah.
So each person has to register beforehand.
Yes.
Picture.
Yes.
So do they ask people to to update the pictures once a year or once every?
Yeah, because registration sometimes is recently, not far away, a lot longer before. Because he is the person to registration. This is gateway just open.
Just open.
Yes.
So the main advantage is that people don't have to bring their ticket, right? They just bring their face, they can go through.
No, they don't need the people. They don't
need person to check it.
Yeah.
The guards.
You guys automatically through this one.
So the problem is that if he's rejected by 2%,
then he has to go see
he has to go through.
Yeah.
Answer some questions.
So that's a lot more trouble for them. Is there any complaint on this? It takes a lot more time for them to go through.
Yeah, because the rejection, he can find the policeman to check it, or I'm is right.
A lot. I think about million. If you get a small number, it's not very
What
hard.
happens,
Yeah.
for example, when I passed through U.S. customs, I remember a time I was standing down this hall to a small room
I see. Okay,
for basically additional security check or whatever reason. I mean, you do it. I mean, you don't. I mean, 40K is.
There is the active reason for face authentication. That is because sometimes the face cooperated is right, but sometimes for video security, that is the person cannot know. So automatically check the person and the tracking and the recognition. This is for they have some picture, but we have to show.
So is there like a time duration expression of the face? Because, you know, people change, even maybe the eyes and the corner of mouth in 5 years. Say, do you take that into consideration?
But
you know, 如果要变的话，5年的话，这个
yes, now have the for face recognition, they have still three difficult. One is illumination. Now is indoor the correct, but although the face illumination is very big. So yesterday I have talked to Dr. Liu. Then second is deep rotated. Sometimes just take a picture in the profile, so it is difficult to recognize. Third is age. Age that is sometimes in the middle age is very small, but in the younger person is much higher variance. And sometimes the older man easy to recognize because older man the face characters is very specialized. So, but in the some young person variance, in Chinese 姑娘18变啊。young lady is change a lot. Sometimes in general in pattern recognition is that if human being cannot recognize, computer recognize too. So that is the common.
So probably the best strategy is that if people complain that he got rejected or she got rejected, you know, more frequently than he thought, then he go through or she go through another registration process. Then it's going to solve the problem.
Yeah, you know. In the U.S. the visa, the image, the face photo required 6 months in. That is easier. That is the same. Your visa, passport visa, required 6 months.
Small. Sorry, but that has its own in terms of importance of getting through. But over here, the benchmark ought to be using the ticket. If I go through the ticket, it takes 3 seconds. I go through, and that's relatively painless job as well. So this one really has to compare with the conventional way of going through it.
Not very clear.
I guess this is not basically for your train station or something.
It's also
it's for customs.
It's the customer.
It's basically it's the border control.
Okay.
I mean, you basically don't wave your passport through.
I have shown you our testing.
Okay.
We have shown you this age variation. The record first the candidate is 1906. It's much higher, lower than others, other variants. This is 1 million. Also, the age variation is first is 77%, so it's lower than others. So age is the big problem. That is. I mean, sometimes in all levels it's 2 years or 3 years, no serious problem. But sometimes reduce the recognition. So face recognition used in the practical, they still have the challenge problem to make the robust for every variation. This is the samples. We have to show you some samples. That is automatically detect face, then zoom the face size and the direction to catch the face and recognize, like this. So other is iris identification, because iris is the most high quality the biometrics. This iris, the localization, take the picture, the evaluation, it can get the good result like this. Testing, the FAR is much higher, much lower. This is a system in our level. And online signature verification. Yesterday I talked to Liu. This signature verification, because in signature is in the law is permission, get the more population. So it is very important. So like this is general signature is forgery signature. So how to get the verification? We have. Sorry, I have lost samples. So here is very difficult for face the online signature, because the signature himself varies. Today, yesterday, sometimes the happy right is angry right is different. So every day, everybody his signature varies, but forgery similar, sometimes similar with your signature. So that is difficult to verification. This is true or this forgery. So how to deal with this problem? We have developed some from the trace writing trace the signature, then use the space signature shape and variance in the not in the one level, but in two statistical information together. So we have use the DSSM. That is the structure statistical structure model, and the time warping. Dynamic time warping and fusion, a different field that get the much higher recognition rate, like this. They have some testing result you can compare with others, because the last one is from the paper published. We have the different three model for here, DSS model, DTW model. This is a fusion model. So the fusion model get the much higher recognition rate, the low error level. This is also different. This is training. This is testing. This is DSSM. DSM, that is on the two level. The variance verification information together. So we have got the. You can look at the 2.69 is much lower than others. They also have some compare with others. Our system is good result. SVC 2004, that is in Hong Kong. This his database to because computation should be have in the same database. So in the database we can get the recognition rate is much higher, much better than theirs. This is our system. This system have both is face recognition and signature. This is online signature. After that is right identification, because everybody know the right is very important. The biometrics features, it is behavior feature. So we have developed a system based on character. Everybody's right performance is on the single characters. So we based on the single Chinese character offline the right identification is one characters. To compare the same like this, same characters, compare the same characters. It is very difficult because sometimes by the export, he have a long time experience to recognize this is the same person right or this is another person right. But we have to use the computer to do that, compare with the different characters. This is now the result is used more than 5 characters. Every character, because the compare is the same characters, every same characters write 4 times, 5 times, just for learning. Then use the 4 characters together. We can get a much higher rate. This is the recognition rate. In 188 person to get the 98.94% rate. And here is the verification. Verification for also for 5 characters. Then for 5 characters to verification. That is FRR 0.15 and the FAR 0.15. That is a good result. But here, right identification or verification is the in regularly writing, not the similar to your writing. That is regularly. This is the more characters is make the recognition rate much high. More characters make verification error reduce much low. So this is sometimes the tested. So 1 characters is just 4% error. If the 4 characters near the 0 error, this tested. Everybody knows the biometrics only one kind of biometrics cannot get the much higher recognition rate. So confusion. Multimodal fusion biometrics is the easy to get the much because different biometrics is information is independent. To confuse can get a high increase. This is where our level. Is iris, face, online handwriting, signature, and others together. This is face verification and the signature verification fused to much lower. Is 0.225%. Also, recognition rate is much lower, increase the rate. This is some demo. Next, some research work in video surveillance. That is person verification, tracking, and some 3-dimension character recognition, and some content, the video content analysis. I have talked to Dr. Liu Li. Their content analysis, it is difficult, very difficult. What is content? The first question is that. So there we have to do the content is based on the human. So what is the principle? First is keyframe, the based storyboard. Take the keyframe. Then you use the principal rules detection in the future movings. Then clustering the person like this. Not very finished that. Okay. There, excuse me, we have to give some. Yes, video.
I need the speaker.
没有 audio,
Okay.
just video.
Video only.
Only. This is the PTZ for so our level. You check my face. Then Professor Dean is recognize me. And after that, other person, student, yes, recognize. This is his name, Rui Yun, and take off the glasses, and Lei Yun also. Like this. Thank you. Thank you for coming.
It's a truly impressive talk. Any questions from the audience?
So how does your lab? But I know that in Hong Kong University they also have a group doing handwriting recognition. So is there any collaboration among different schools in Greater China area? Or is there any internal competition or something to see whose algorithms are doing better than the other?
Yes, I just compare with the SVC 2004. That is this conference on Hong Kong is Hong Kong Science Technology hold this competition. We just use. I have not to see. I just take the database.
I asked you earlier question about if you don't compare, if you don't fix the training data, the answer you gave me is that people are free to use whatever training data they have. It will be very hard to compare which algorithms are doing better than the others. Right?
Yeah, that is different. For verification, just take this true or not. True or not. The other database hard to use. How to use? If you can find some method, you can use it. Make your algorithm better. But for recognition, that is dependent on your system, how many person in it. So you do not need others. So only you can improve your algorithm. It is on the verification. Because verification, that is negative samples. But negative, you can choose a lot of negative samples because we choose this face it is me or not. False samples, a lot of person always the false. So that is no matter.
Multimodal authentication, you also consider doing the use of audio as well?
Audio, yes. Our other group use the speaker identification, but I have not. So I have, but easy because the frame biometric fusion, multimodal biometric fusion. That is the frame is okay. Every new biometric can end it easy because they have the different level. It is it's decision level, yeah, and the decision level easy, but also for verification, that is classification level. It's just to give a sample together. We can train. So the same frame biometric fusion unified frame have established in our lab. So easy to others.
A writer of the recognition. You use the same character. You ask people to write the same characters.
Same characters.
I was wondering if you can train on one set of characters or recognize different characters.
Yes, we have done this one because sometimes we just finish a project because if we have this system is more than 500 person. It is hard to find the 500 person have the same characters. Cannot use this system. So we just we can do that. It's compare both. It's the same character, but a different person we can use different characters. Both together. So it is a fusion scheme. So we finish that 500%, but in the different characters. But compare by both is the same characters. Like this.
Question
for NSR here, I assume PC?
Yeah.
So what type of collaboration are we thinking with Tsinghua University? Obviously, they have a whole list of different possibilities. So after this talk, what's next?
Microsoft Research isn't collaborating with Tsinghua is not collaborating with Professor Ding's lab specifically. This is just one of our gratis visitor programs. We invite renowned researchers and professors to talk in this lab, and it is free for you guys to pursue further collaborations. I'm not aware of any collaboration specific. More or less professional.
I hope to find some way to cooperate each other, please.
So I understood from you presented a few methods for verification, face recognition, iris, and right hand. And iris got the best result of iris.
Yes.
And in terms of speed, what's the fastest method to use? Which one is not? If you have to process, which one has the fastest relative recognition? Speed, how do they compare?
You say it's iris. Yeah, iris is most difficult. It's hard to catch the image. It is very hard. A small one take the image, they look at it. So sometimes it need, and not like face. Face you don't care. I can take your face, but the iris should be must have to have the cooperation. The can catch the face iris image.
So I'm thinking, if you were having a practical situation where you had to choose which method you're going to use, you've got these trade-offs. Some are easier to
Some face signature right. That is easy because you have to write your signature. You easy, but you have to write paper in your characters, so it is easy to find.
I've noticed that you had a slide in which the handwriting recognition was compared between different engines, including your engine. And I was wondering, do you have some reference for how the testing was done? Was it a specific company that compares them? Was the comparison done in your office, or?
Okay, are you talking about a ScanSoft result? Are you talking about a ScanSoft?
No. Handwriting recognition. I've seen a slide in which the Tsinghua University engine was compared with Hwang, with Fujitsu, and so on. And I noticed that Microsoft was not there, so I was wondering how it was done and why Microsoft is not there.
This is for printed document.
For printed documents. Okay.
Printed document. That is
by third party.
Yeah. That is the Microsoft cooperation with ScanSoft testing our engine.
Okay, I was under the impression.
Yes, yeah.
Also, there's the impression that it was for handwriting.
No.
Printing.
No.
Oh,
that is printed.
So Hwang is producing a printed recognizer as well?
Yes, printed. Hwang is competitor with us. It's a long time. But in the A63, more competition, our recognition rate is higher than Hwang. But in the marketing operation, is Hwang much better than ours because our in Tsinghua University have not done some marketing the processing.
You talk about this document analysis or the newspaper you have been published.
Yeah.
What is the application area for this technology?
Yes. With this one just developed. Sometimes I have this new developed and added to our product. Move to the product, improve the product performance. This is
So it's a pre-processing.
Yeah.
Okay. So did you try to compare the performance and the accuracy of the document recognition engine with other companies? I was working, for example, before coming to Microsoft for CCS, a German company that did the same thing, and I was wondering how they compare.
Yeah, well, the computation we have got is the character recognition rate. But for the document recognition computation, we just attend ICDA 2005.
Okay.
Yeah, well, in ICDA, the first and second all belong to our level.
Competition in the HDL analysis, you're talking about the competition?
Yes, yes.
Oh, so you took the first and the second place?
Yes. Much higher than others.
Okay.
Any more questions? Feel free if you want an individual time slot with Professor King.
Thank you. Thank you.